Howdy! You may notice I'm in the top right-hand corner of the screen now. Some students were complaining that sometimes my face was covering some of the words, so we're going to try being in the top right-hand and see if that works a little bit better. In this unit, we're going to be going over classes, where we can define our own object types. Classes are fairly complicated, and the notes we're going to be going over won't make a whole lot of sense until we see some examples. So we're just going to go ahead and power through the slides, take notes on the format of how we do something and the terms, and then when we do examples, it'll start making some more sense. What are classes? A class is a definition file for an object type. Writing classes allows us to create our own types. These types can store multiple pieces of information. For example, if you wanted to store data on 5 students and a student had a first name, a last name, and an ID, you would need 3 variables to store a student. If you had 15 students, you would need 45 variables to store these students. In this chapter, we're going to learn how to make a new type called student. A student could have a first name and a last name. And then we could create 15 students and have only 15 variables instead of 45. Encapsulation is the term for when multiple pieces of data are stored into a single class. Parts of a class. We have attributes, which are going to store data. We have constructors, which are special methods that are used to create an object. And usually, they will set the starting value of all the attributes. Methods. We've already talked about methods before, but classes are allowed to have methods. Methods for classes are usually actions the class can perform. Usually these actions access or manipulate the class's data. Most classes will have all 3 parts, but each part is optional. Like you may have a class that just has attributes. You may have a class that has attributes and constructors. You could have a class that just has attributes and methods. So forth. You could even have a class that has none of the 3. But if a class had none of the 3, it wouldn't be very pointful. It really wouldn't do anything. So we won't see any like that. The format for a class is public class, class name. Then you have your curly braces. Inside the curly braces we have attributes, constructors, methods. They do not have to fall in this order, but we're going to put them in this order so that we know, hey, I need to know if I created an attribute or not. Well, you go to the very top of the file. Hey, I don't have a constructor. So you would just go above the methods and write one. If you follow this order, you'll be able to easily find things. If you just put attributes wherever you want, then when you go looking to see if you made an attribute or why its value is messed up, you would have to look in the entire file. So we're going to follow the order of attributes, constructors, and methods. When you read other people's code, this is the format that's usually followed. Creating an attribute. We list off the access level, followed by the modifiers, then the type, then the attribute's name. Access level determines the amount of access other files will have to this attribute. Modifiers are additional properties for the attribute. There I wrote addition, but write down additional properties for the attribute. Access levels. Public, data can be accessed freely outside of the file. Private, data cannot be accessed outside of the file. We use the term information hiding for when we make attributes private. We're hiding the information from other files. Modifiers for an attribute. Final makes the attribute constant. We've already talked about final before, but I'm listing it because you need to know it's one of the valid modifiers. Static makes the attribute static, meaning that every class shares a single instance of that variable. Static attributes are referred to as class attributes. Non-static attributes are referred to as instance attributes. Static. Let's assume we have, static. We're going to go through an example of what this really means. So, assume you have a class that defines a family member. Let's say a family member has a name, they have an age, and they have a car. Now assume you have family members Bill, Jane, and Ted. So, example 1. Let's assume car is static. That means everybody shares car. If Billy wrecks his car, because there is only one car, Jane's car and Ted's car are wrecked too. Because everybody's sharing one car, if one of them gets wrecked, they are all wrecked. If you make something non-static, everyone will have their own copy of that variable. So if Bill wrecks his car, if Bill wrecks his car, because everybody owns a car, Jane's car and Ted's car are fine because there are actually 3 cars because there are 3 family members. If there are 50 family members, there'd be 50 cars. If it were static and you had 50 family members, there would still only be 1 car. It'd probably be a little bit hard to get places because everybody would want use of it, but there would be only 1 car. Constructors. The format for a constructor is public, class name, parenthesis, parameters, parenthesis, curly braces, and then code to initialize the attributes. Some things you should know about constructors. Constructors can be overloaded, so you can have multiple constructors. Constructors do not have return types. If you look there, it says public class name, then it goes directly into parameters. It's not public void. If you write public void, you have not written a constructor, you have written a method. Primitive attributes not set by a constructor are set to 0 or false. So if you forget to set something, it'll be set to 0 or false for primitives. So why I say or false is Boolean's a primitive, so it would set Booleans to false. Object attributes not set by the constructor are set to null. Null means nothing. You can't access anything from nothing. So null's usually not a value that we want. But we'll get into null later in the chapter, and a lot of you will get errors about null in the unit, and you'll get very familiar with what null means. A constructor with 0 parameters is called a default constructor. If you write 0 constructors, so if you choose not to write any constructors at all, there will be a hidden default constructor that does not set any values. That means all the primitives are going to be set to 0 or false, and all the objects are set to null. If you write at least 1 constructor, there will not be a default constructor unless the constructor you wrote was a default constructor. Methods. When we're writing methods, again, we have access level, we have modifiers, we have return type, and name, followed by parameters. Access levels. Methods have the same access levels as attributes, so public and private, and they work exactly the same way. Methods have the following modifiers, final and static. They have the same modifiers as attributes, but they don't both function the same. Final, it's different than final for attributes, and it will be covered in the inheritance chapter. So until we talk about inheritance, we can't talk about what final is going to mean on a method. Static makes the method static. Static methods are referred to as class methods. Non-static methods are referred to as instance methods. So if you want to know what it means to be a static method, it means you're only allowed to access static attributes. Many of you have already heard the definition for this because anytime somebody says, "Hey, what is this?" I always respond with the following sentence. This is a keyword in Java that refers to the current object's instance. An instance of a class is an object created from a class. For example, string is a class or type, and gem would be a literal instance of type string. For now, we'll use this when we write constructors and mutators. When writing these methods, usually we will have an attribute and a parameter with the same name. When this happens for a short time, you have 2 variables with the same name. When we want to access the attribute, we say this dot variable name. When we want to access the parameter, we write variable name. Accessors. Accessors are methods that give public viewing access to private attributes. Format. Public, whatever type of variable you're trying to access, get variable name. And the only line of code in an accessor is return variable name. An example would be if we had a private attribute int age, the accessor would be public int, because age is an int, get age, because that's its name, and notice age has a capital A because it's the second word, get age. Then return age, and we return it like it's actually spelled, which is just age. Mutators. Mutators are methods that give public change access to private attributes. the format is public void set whatever the name of the variable is, followed by, in the parentheses or your parameters, you'll have the type of the variable you're wanting to change and its name. Then when we go to change it, there'll be two variables with the same name, a parameter and an attribute. So we say this dot variable name to access the attribute equals variable name, which is the parameter. An example, if we were talking about private age again, we'd have public void set age int age, this dot age equals age. We'll see an example of the equals method. When I do my examples, we'll do an equals method. We're also going to do a toString method so you can see what they really look like. ToString method. All classes have a built-in toString method that returns a text representation for the object. By default, this method returns the class name and an @ followed by its memory address. So for instance, if you were to print off a scanner, it might say scanner at A537F, and that's not really useful to us. Usually, we would want the toString method to return a string that has the object's important information. Generally, we'll be writing our own toString methods. The format for writing a toString method: public string toString, and then inside you'll have code to return a string containing information about the object. Creating objects. Once you've written a class file, you can actually create objects. The format for creating an object from a class is class name or type, variable name equals new class name, parenthesis, all the parameters the constructor wants, close parenthesis. An example of this is strings are actually created with string s equals new string, quote, whatever you want, Bob, quote, close parenthesis. We do this so often the computer has shortcuts, so when you do string s equals quote Bob quote, what actually happens is new string parenthesis quote Bob quote. When we create a scanner, we always see the new word. So scanner keyboard equals new scanner system.in, and it has a parameter. The parameter is the data stream we're gathering from, which is system.in. Accessing attributes. If you have a public class or static attribute, you can access it either by saying the name of the class .attribute, like math.py, or we can access the attribute by saying a particular instance of the class .attribute. So we'll see that when we're doing our examples. Accessing public instance, meaning non-static attributes, is a particular instance of the class, variable name .attribute name. Accessing private attributes requires the use of an accessor, variable name .accessor. So again, we'll see examples of all this when we do our examples in a few minutes. Changing attributes. So if you have an attribute and you'd like to change its value. For public static attributes, it's class name .attribute equal value, because it can be accessed through the title of the class, or a variable of a instance of the class .attribute name equals value. Changing a public instance or non-static attribute, its variable name .attribute equals value. Changing a private attribute name, changing the value of a private attribute is variable name .mutator, open parenthesis value parenthesis. Accessing methods. If we have a static or class method, it can be accessed either by the class name or through an instance of it. So it can be class name .method name open parenthesis parameters, or variable name .method name open parenthesis parameters. Accessing public instance methods. Variable name .method name open parenthesis parameters.